So, good morning, afternoon, evening, everyone, wherever you are. We will wait for a couple of minutes for others to come into the webinar, and then we will start for today's session. Okay, I believe we can start now. Good morning, afternoon, evening to everyone, and welcome to the first session of the Coastal Resilience webinar series. My name is Edwin Espina. I'm a fellow researcher at the UN Decade Collaborative Center for Coastal Resilience at the University of Bologna, and I am very happy to be your host today. This webinar marks the beginning of a new series that will take place twice a month on Tuesdays, bringing together experts, practitioners, and students committed to strengthening coastal resilience worldwide. This series is part of the Coastal Resilience Training course, co-growth, which officially started on January 27 and it will run until April 11. This course has been designed to equip early career professionals, scientists, and policymakers with the necessary tools to tackle the challenge of coastal resilience sustainability. We are proud to share that 25 students were selected from over 500 applications from all around the world. This reflects the high level of interest and the importance of this topic. Now the selected students will follow a comprehensive course over 10 weeks, structured around 5 key modules or pillars. These modules are designed to equip them with deep understanding of coastal resilience and its importance for business, as well as practical skills for addressing coastal hazards. Finally, the course culminates in a workshop that will be held in Italy. It is important also to mention that all expenses, including travel, accommodation, and tuition, are fully funded for the selected participants. And before we begin, I would like to take a moment to acknowledge this partnership alliance that has made this webinar series possible. This initiative is hosted by a collaborative network of institutions committed to advancing coastal resilience, sustainable growth, and climate adaptation. Our key partners include the UN Decade Collaborative Center for Coastal Resilience, Deltares, experts in water and coastal management solutions, and the CMCC, which is the Euro-Mediterranean Center for Climate Change, leading climate research institute, and the University of Bologna. These organizations play a fundamental role in shaping the discussions and research that drives coastal resilience forward. We encourage all of you to connect with them, explore their initiatives, and engage with the broader community of practice, where you can continue the conversation beyond this webinar. And now let me introduce our speakers for today's webinar. First, we will have a presentation by Dr. Godwell Nhamo. He's an expert in environmental policy, climate change governance, and sustainable development with an extensive and sustainable with an extensive experience in climate resilience, adaptation, and disaster risk reduction. And then we will follow a presentation by Cecilia Bittoni. She's the program manager at the UN Decade Collaborative Center for Coastal Resilience, whose work integrates sustainability with financial strategies to support resilient decision making. Just a short bio, his background and expertise. Dr. Godwell Nhamo is an expert in environmental policy, climate change, governance, and sustainable development. He holds a PhD from Rhodes University, a master in environmental science, and a bachelor with honors in urban and regional planning. He also completed a postdoctoral fellowship and a project management program with an NRFC1 rating. His research focuses on climate resilience, adaptation, disaster risk reduction, and the green economy, contributing to policies for better environmental governance and sustainable development. Before we begin, each of our speakers will present their insights, and we will follow with a Q&A session. So please feel free to submit your questions in the Q&A section, and we will address as many as possible. Finally, please note that this webinar is being recorded and it will be made available for educational and promotional purposes. So by participating, you consent to this recording. Without further ado, let's get started. I'll now hand it over to our first speaker, Dr. Godwell Nhamo. Dr. Nhamo, the floor is yours.
Please, can you confirm if you can see my presentation, and that is going to be getting into PowerPoint?
You may want, yes. Now it's great.
Okay, that's fine. Just give me a sec because I see. Okay, that's fine. Right. Afternoon, good morning, good evening, wherever you could be. I am going to be talking, getting right into it, and I'm going to be talking around net zero emissions and climate smart wastewater treatment works. That's WWTWS there, for coastal resilience in general, maybe globally, and also specifically in South Africa. In terms of my presentation outline, I will start by getting into shopping, like a typical TV or radio advert. Then an overview on UNISA catalytic niche areas. Then I'll get into the rationale and background. I will move as to why coastal businesses should worry about wastewater treatment works. Then I move on to focus on South Africa's Buffalo City project we are setting up, and I will conclude my presentation. As I said, going into the shop, we have got two book chapter calls that we have pitched. The other one, I think we are going to be finalizing it during my stay here with Nadia and team. But the first book chapter calls have gone out, and if you're interested, please drop me an email or WhatsApp. You'll see my details at the end of this presentation. So the first book call is on climate change and coastal resilience in Africa. Dr. Lazarus Chapungu and myself, we are editors. The second book, which is like it, is going to be looking at perspectives in ocean, marine, and coastal governance. we should be able to flight the advert for call for abstracts in the next week or so. Now, from the university I'm in, the University of South Africa, we are emphasizing a lot of work or research and setting up of new degree programs in 10 catalytic niche areas. And of course, we can see the first one there, marine and coastal studies, is one of our emphasis area, and the rest you can read on your own from the slides that will be shared to you. Now, I thought maybe it would be interesting for us to start with the rationale and background in terms of wastewater and coastal pollution as such, or coastal impact. So what I did there was just to get into a bit of a bibliometric analysis to just check what is happening there. The search string I used was wastewater, sewage, or sludge, or coastal pollution, or ocean pollution, sea pollution, marine pollution, estuaries pollution, and see what is happening in terms of the science or knowledge that is being generated. And we discovered there, starting from about 1968, we had just a little bit of publications, but now these have now skyrocketed, starting maybe around 2018, moving forward. And just in terms of the authorship affiliation, so there when you look at you discover there we are talking about maybe countries with author affiliations of about 3 documents, about those that are having close to 100 documents affiliated to them. It all depends on the coloring there. So discover there a number of countries that actually don't even have some of the publications, that have got less than 3 publications that are talking about wastewater and the coastal pollution. And of course, when you talk about maybe some of the developing regions, South Africa is not doing badly. And of course, we've got other countries there like Tunisia, North of Africa, they're not doing badly, but the rest of the continent is not doing that well. And I'm also surprised in terms of Australia, not even having a few authors affiliated to that, having less than 3 documents with all authors affiliated to that area. So really, this just gives us an understanding in terms of how the science on wastewater and coastal pollution is being generated. And then when we start now talking about this, it can actually, for us as researchers and the young academics, young researchers, you can see the gaps that are there in terms of knowledge. And then where we want you to start getting in and contributing. We also, I also did also just a quick from Scopus database, a quick analysis of what is being published. So we discovered about 79, almost 80% of the work done, journal articles. Then of course, this is followed by conference papers and of course, review papers as well, with then just a little bit in terms of book chapters and books. So you see, this is actually one of the reasons why we decided in our team that we might need then to pitch some books. We need now do more in terms of writing books that are going to be addressing wastewater, coastal pollution, ocean governance, coastal resilience. You can see with in this space with the amount of books that have been published, just about 0.2% of the 2,820 documents that were retrieved. So basically, we are actually mapping a research gap here that is of interest to us as young academics or as emerging scholars. Also, in terms of the disciplines that emerge, the bulk of the publications are from environmental science, earth and planet science, then agriculture, and of course followed also by engineering and some few others. But then that also gives us an understanding in terms of where this work is coming from. Then of interest there was the issue about documents by country or territory. Of course, the US is dominating, China as well, UK is dominating. And this occurred in terms of the top 15. But I went further to check. Since I was from South Africa, I was interested in checking where South Africa really is sitting there. And what comes is the effect that it comes 22nd in terms of the productivity, in terms of the documents that are being generated. And you discover maybe most of our countries they are not anywhere close to that in terms of the document productivity. So it just also opens additional gaps in terms of what we need moving forward. Now, what I did then was to import the data and bring it to Force Viewer. Force Viewer is one of the bibliometric analysis software that we use, and it's good in terms of mapping clusters and also mapping research gaps that will be needed. So the reason why I'm doing this is almost like an academic setup. So I thought I should start by doing this for our own understanding on, even if you're going to pick some projects in the future, then these are some of the techniques that you can use to open up your research gap as scholars and as researchers. No, what are some of the major issues that are coming there? So you discover that we've got around plastic pollution, aquatic ecosystems, fresh water, health risk, wetlands, surface water, around beaches, river pollution, is around groundwater pollution, is around focal coliform, coastal waters, water purification, phosphate, sewage contamination, sea pollution, shipping, heavy metals, sewage treatment plants. We've got this around sediment pollution, estuarine pollution. We also got things that are coming about pesticides, pharmaceuticals, aquatic species at risk, and aquatic ecosystems. So this actually oil spills as well. This is actually some kind of like, these are actually the heat maps in terms of what science has been researched following those 2,820 articles. Then when you look at maybe the time frames, which is also something that we do in Force Viewer, you discover that of late or more recently, issues that are coming there around pharmaceuticals, risk assessment, wetland, aquatic species, aquatic ecosystem, plastic pollution, fresh water, health risk, river pollution, haze, human activities, and anthropogenic activities, organic pollution. These are some of the marine sediment, some of the most recent issues that are coming through. But you also discover there is a lot of old research areas like water pollution, phosphates, marine water pollution, industrial effluent, organic compound, trace elements, invertebrates. There are issues in fisheries that also are coming in terms of maybe old but viable areas that we want to look at, and the industries that are associated with that. Something that is of interest then is we, in one of the works that we've done with my team, we tried then to look, this is South Africa, for those maybe that have not been there or that have not got to see the map of South Africa. What is something that we've done is we tried to use data available from our official weather services and map the hazards that actually have been occurring since 1920 to about 2023. These are actually reported in one of the databases. So you discover there in terms of how South Africa is oriented, we have got about 3,000 long kilometers of coastal of a coastline. And when you look at the hazards there that are there, you can see they are dotted all over along the coastal areas. And for example, when you look at Western Cape province, quite a chunk of disasters that are actually hitting there, from extreme rainfall, drought, field fires, floods, sea waves, hailstorms, heat waves, tornadoes, lightning, mist, fog, mudslides, snow, storm surges, tropical cyclones, and windstorms. So all these disasters, actually, they are occurring in the country. And when we talk about coastal resilience, these are some of the issues then we want to know. Here, we are not showing about intensity, just talking about where they are located in the spatial distribution. But there are other issues in terms of frequency, in terms of intensity, that are not coming in this slide, which we know are happening. And these issues are of interest to industries, to businesses, and to us as young academics and researchers. Now, let's get to know what is apart from now. We are now moving from the science mapping that I was doing. We want to move now to say what has been some of the recent issues reported in South Africa in the area that I'm looking at. You discover there, for those, some of you maybe that have been to South Africa, some of the locations you might know. When coastline sewage polluted pose threat to holiday makers and the environment, our aid the businesses. Umgeni, a river of sewage flowing through Durban. So this actually is a 2022 article, the first one. The second one is a 2024 article. This is last year. We are facing the same problem. Cape Town fights uphill battle against ocean and waterway sewage spills, 2024 article. The public being warned and informed appropriately about wastewater spillage in Cape Town. So what actually Cape Town has done, it has been applying to the National Department of Forestry, Fisheries and Environment to discharge raw sewage into the ocean, because saying it's wastewater treatment and sewage network capacity has been overtaken by the rapidly increasing population in the city, in the metropolitan. So then they've applied to be given a permit or permission to dispose direct sewage into the ocean. Then, of course, you see alarm is more dead fish discovered in Durban's Umgeni River beaches and beaches close. It's all about sewage too that are there. So you now discover that the challenge you are facing here, it might not only be a South African challenge. You go maybe to East Africa, you might see this in Mombasa, you might see this in Dar es Salaam, you might go to the small island states, you can see this maybe in Fiji, you can see this in Mauritius, you can see that this in Trinidad and Tobago, you can see this across Latin America. So these are some of the challenges that we are facing really in terms of how raw sewage or half-treated sewage is becoming a coastal hazard, and thereby limiting resilience in terms of maybe livelihoods. We know that there are small-scale fisheries, there are also large-scale fisheries, there are also shipping activities, there are tourism activities in beaches. So we are saying that if we are not careful in terms of how we manage wastewater treatment, then it's going to be a problem in terms of building coastal resilience and also resilience for businesses. Business actually can close due to polluted beaches, because apart from those directly involved in tourism, there are also people that set up big coastal businesses that support these activities. So if there are no visitors, then it means at times business comes to a complete halt, like during the times of COVID. Now, what is it that we have done now as the University of South Africa? Also, this is also quite an interesting one. This is a paper that was published in 2024 by Naidu et al. There, focusing on that side. And they say they investigated socioeconomic impacts of the 2022 sewage spills along Umhlanga Rocks coastline and beach area on businesses. And of course, the findings are quite intriguing. The findings reveal significant negative impacts on different sizes of businesses, from reduced number of tourists, total closures, and sometimes layoffs, or maybe reduced working days and working hours. So this is actually quite a serious issue where businesses can come to a standstill because of sewage spills, wastewater not being treated properly. So this is one of the examples, and in academic work, recent academic work from the Durban area. Now, what I've done now, I presented part of this in the plenary this morning. What I've done is the University of South Africa, we have actually partnered with one of the metropolitan municipalities. We deliberately then moved away from getting to Durban, getting to Cape Town, where a lot of people want to, and even other universities are going. Since we've got such a large coastal area, we decided, no, we'll identify one of the metros, and we've identified a metropolitan municipality called Buffalo City. It's in the Eastern Cape province. Our research site is part of our bigger program focusing on a smart and resilient Buffalo City metropolitan municipality, and we are setting this up as a living lab. And then, as you are under my voice now, we are actually inviting partners to set up, because this is almost like a virgin research area where we are saying or whatever the type of research you want to deal with coastal resilience, ocean observation. The site is there, the municipality has given us permission, and we are there to partner. Please come, let us actually put our best foot forward in terms of researching that. The project is also part of our endorsed decade action, the UN decade action number 42.5, which is global coastal ocean restoration and resilience. We call it Restore Our Coast. These are some of our partners: CMCC, Heroin, IGP, Placon. And we are saying that as we move towards establishing this site or family establishing this site, there's a lot that we can bring that's going to assist business and local communities in building coastal resilience. Now, this is the site that we've been given for a project that we are calling Buffalo City NetZero and Climate Resilient Wastewater Treatment Works Living Lab. So we are planning then to revamp that site, maybe bring new designs. And in this project, some of the issues that we are looking at, there are about 8 major issues that we are looking at when this project is fully commissioned. And it also aligns with the Sustainable Development Goals by 2030 and also our UNISA catalytic niche areas. Then the UN decade, UN Ocean Decade. So when fully commissioned, this project, which is part of a bigger program that I don't have time to dig deeper into now, we'll look at full automation of the selected wastewater treatment works. We are looking at installing and generation of renewable energy, solar, mini hydro, and biogas. We are looking at effluent recycling for industrial and all domestic use. Mercedes-Benz, one of the global brand, has a plant, a manufacturing plant in East London, which is within the Buffalo City. We're also looking at a climate risk and vulnerability assessment leading to climate resilient systems, including baselines for loss and damage. We are looking at harmonization of scientific, traditional, local, indigenous, and other forms of knowledge, systems, and knowing. Number 6, we are looking at exploring digital twinning possibilities. I'm excited. I've already opened up links here during the assembly with CMCC and Heroin. We are looking also at investigating potential for carbon credits and trading, if any. And this project is going to address the circular economy movement. So what we are simply saying there is, like, wherever you are, you can also take this template and try to innovate. You might want to plug and play, or you might want to plug, innovate, amend, and play. But eventually, I'm saying, when we start talking about coastal resilience, we can't exclude wastewater treatment works because it's so embedded in coastal resilience issues. In terms of my conclusions and the way forward, there are a number of bullets there that I've said, which I think are going to be of use to us. Number 1, wastewater pollution diminishes coastal resilience and impacts negatively on livelihoods, and the problem across the world, especially in the global south, is huge. So when talking about coastal communities and livelihoods, we are talking also about businesses as key stakeholders. So we are saying that when actually wastewater pollution is not addressed, it diminishes even business opportunities in those coastal areas. Key impacts include reduced tourism activities, polluted beaches, etc., reduced fishing activities, and ill health for both human and aquatic environments. To this end, the Buffalo City NetZero, NearZero emissions and climate resilient wastewater treatment works project remains a must-do intervention measure, presenting a prototype for other regions. By prototype, you are saying we can, wherever you are listening to me from now, you could actually initiate such a project and also maybe take some of the elements in implementing it. However, the main challenge in realizing the plan is that the project or living lab requires significant funding. And we are saying the public-private partnerships remain a viable option. So as businesses, and governments and other entities, the idea of coming into partnerships to address wastewater treatment challenges in coastal regions remain at our doorsteps. So we need then to put our heads together, put our minds together, put our resources together so that we can be able then to address the challenge of wastewater treatment. And the challenge of wastewater treatment also comes in regions where there are already water thirst and water is, if water supply is even a problem. So you're saying then when you close the loop, we could actually improve this water supply situation if we can treat it to potable or domestic use standards. The University of South Africa is the youngest implementing partner for Restore Our Coast. And as such, the researchers will continue learning more from established partners. And like I said, we are inviting all the organizations to come and join us as we deliberate and as we move forward in terms of implementing this. This project is also coming as part of the bigger work streams. Like I said, we have established a research program called A Smart and Resilient Buffalo City. So there are many other projects that are within work packages that are within this program. For example, we're talking about maybe climate smart agriculture, we're talking about loss and damage, we're talking about resilience, we're talking about early warning systems, we are talking about general digital, ocean digital twinning. We are talking also around researching for development. We're talking about innovation, citizen science. All these issues, they're part of our bigger mission in terms of the program. And this is why I was saying we are open for business in terms of doing research. We are open for deployment of new technologies or low-cost technologies in research in this wonderful site that is along the Indian Ocean in South Africa. I will pause here. Those are my details for those that might want to link up with me. I will pause for some few seconds so that maybe you can take a picture. You can write to me. My name is Professor Godwell Nhamo, and that is my email, and that is my WhatsApp number. That's supposed to be 27 for South Africa plus 27 7316 3114. And I'm also on WhatsApp. You can just briefly introduce yourself, tell me what you need. You need to join our team, all that kind of stuff. You need to visit. We are open and we're excited to be hosting you if you're going to visit. Thank you. And off our facilitator, I will stop here.
Thank you very much, Professor Nhamo, for this insightful presentation. Now we would like to open the floor for questions. So if you have any questions, please use the chat or raise your hand. I believe it's better if you use the chat, and we will call on you. We already have some questions in the chat.
We have questions, Edwina, in the Q&A box.
Yes, the first question is from Carla Schulte. She asked, perhaps I missed it, but why France is the only country in deep blue on the map? I believe it was one of the first slides.
Yes, so France is a deep blue. It means it has got the highest number of documents, the highest number of research coming from France in terms of research on wastewater and coastal pollution. So this is actually a very good indicator. The researchers there in France have been doing work in terms of that. So it means when you start reading, maybe there could be a lot of maybe cases or case studies that we can learn from France. So those that are lighter, or those that have got nothing, it means there hasn't been much coming from those countries in terms of wastewater treatment, wastewater, and coastal pollution.
Okay, thank you. And then we have another question. Which role plays PFAS in your studies? As for example, in the north of Germany, they just found a big quantity in the form of waves.
I am not sure what PFAS means there, because it has been put in. If maybe the originator can just explain what PFAS mean, that will help me.
Well, PFAs usually are this group of human-made chemicals that are used on different industries to protect from heat, water, and oil. Like they are used in Teflon, in water-repellent fabrics, and they are.
Oh, yes, now I'm with you. Now this is the interesting part. So you're saying that a lot of pharmaceuticals, they find their way into the ocean. So number one, if for example they are just washed on surface, they will also find their way into the ocean. But also from the human excretion system, detergents in the kitchens, in the industry, and otherwise. Then the channel is through wastewater treatment. Remember, we channel all this to wastewater treatment works. So we are saying there, it's then in the wastewater treatment works that some of those PFAs should actually be removed or treated to acceptable standards before the water is disposed into the ocean. And by the way, all coastal wastewater treatment works, at least in South Africa, they are supposed to be disposing about 7 kilometers into the ocean. So you need to have a pipe that then channels that wastewater about 77 kilometers into the ocean before it can be disposed. So you might discover that at times, no, it's just disposed within a very short distances, and then that can lead to a lot of pollution in terms of beaches and other uses. It could be aquatic environments, fisheries, then it can be a problem. So this is actually why then we are saying when we talk about net zero emissions and also climate resilient wastewater treatment works, these are some of the issues that we're talking about. When we talk about net zero, I say net zero emissions of effluent into the ocean. We're talking about net zero emissions of carbon into the atmosphere. So we're saying the modern wastewater treatment works should actually be trying to aim for net zero emissions and also be climate resilient. Why climate resilient? I can reflect in terms of the map I showed there. It could be storm surges, it could be tidal waves, it could be sea level rise flooding, it could be inland flooding. So we discover if these wastewater treatment works are not climate resilient, we are going to face those challenges where they can be destroyed during storms, like what have happened in KwaZulu-Natal in South Africa. During some of these heavy rains in 2022, 2024, you discover that the sewage network, wastewater treatment networks, they are damaged by these disasters because most of them were constructed when climate change was not an issue. And I say moving forward, there's no way in which we can just sit these wastewater treatment works without having them to be climate resilient. It's going to be also a matter to say, what do we do also with the old wastewater treatment works? We might need to revamp them, or some might actually need to be abandoned as there is a coastal retreat. So there are many issues that we are looking at when we're talking about net zero, near zero emissions and climate resilient wastewater treatment works. Thank you, and over.
We have more questions. If we have still some time, then Kahina asked, do you involve local communities' participation in this Living Lab project? And if yes, how are they involved?
Yes, so what I've done now, we just went to establish the site. So we spent a week. So when we spent the week, it was mainly to deal with the administrative structures of the metropolitan. So in terms of admin structures of the metropolitan, we had the provincial government, we've got the local authority, like engineers that are dealing with the sanitation and water division. We had also other represented national government offices or officers, and then we had universities that are going to do the research. So the first project that came on board was exclusively a project from the municipality, which is wastewater treatment works. But there are other projects that we are going to be sitting. For example, we're talking about early warning system, where we are even going to go and now talk to the chief traditional leadership, local communities, depending on where we want to sit the research project. But what we are emphasizing in is like we need to co-create the research agenda. So in this case, part of the work streams that we got, it was suggesting that were coming from the metropolitan municipality, Buffalo City, and other government departments that were represented during the 1 week long exploratory visit. So moving forward, definitely we are going to be involving the local communities, especially we're going to talk about citizen science. We are also hoping that maybe we might sit a project on early warning systems where we are talking about maybe use of app-based use by local communities. But we are also talking about maybe having international collaborating partners, because we are looking a lot in terms of how do we integrate artificial intelligence into disaster risk reduction and management. For example, early warning system, search and rescue, identification of damage, and also monitoring recovery. So we are interested in that side. And like I said, also in the plenary today, and I'm saying it now here, we are also interested a lot in digital twinning. So we are saying possibly if you get a partner, we'll then maybe try to do a digital twin of the part of the ocean that is falling, the coastline that is falling within the metro that we are dealing with. So there's still a lot of areas that we need to deal with. We've also consulted with the businesses that are there in the area in terms of maybe what could be the expectation, and eventually maybe drawing uptake agreements in terms of the recycled water. You would need businesses to buy into that. We also need maybe issues around investigating on perceptions. You know, people, some in terms of communities, they might not be happy to use recycled water because they still believe maybe it's not potable enough. So definitely, if we're going to close the loop to potable water levels, the communities, the councillors, and everybody in the city needs to be involved so that they understand where we are coming from and where we are going. But the government is also pushing strongly towards this idea of closing the loop and recycling water, because the country is a water-thirsty country. We import quite a lot of water from neighboring countries like Lesotho and others. Thank you, and over.
Thank you very much, Professor. Then we have a question from Susanta from Sri Lanka. She asked, how did you conduct the risk and vulnerability assessment leading to a climate resilience system, including loss and damages? Did you follow specific indicators to measure risk or vulnerability?
Yes, so far we have not done the baseline for that. So part of our work in the entire Buffalo City Metropolitan, which is one of the work streams, is to develop baselines for loss and damage. So for example, we want to do the geocoding of properties. It could be government buildings, it could be other residential areas. We want to do geocoding, assess the structures in terms of the state or maybe the monetary value. Also assess baselines for road infrastructure, sewage infrastructure, waterworks infrastructure, and other infrastructure. So this is what I'm saying. This is a bigger program, research program, where I'm saying everything to do with coastal resilience we want to bring. So there is actually one of the work streams that is looking at smart city. So even like a digital city, all these things are going to be part of the bigger agenda. But in addition to that, there is work that has come up. We might need to follow it up, I think, with the UNEP, or maybe Stockholm Environment Institute and UNEP. They are busy trying to to come up with indicators for loss and damage, and also even the UNFCCC, where I'm sitting as one of the non-economic loss experts. There's a lot of talk around setting indicators for loss and damage. So this also is going to be part of the project in terms of calibrating or developing indicators or refining indicators at a local level in terms of loss and damage, so that when it comes to attribution issues, then we'll be able to have baselines that if a disaster hits, then we should be able to refer to, say, the state, what was the former state and what is the state after the disaster. So this is actually work in progress that we are trying to see. So there is a big chunk around loss and damage. And by the way, We have also done proposals that are awaiting funding in terms of a number of research chairs that are coming from here, and then we've opened them up. So we've got a chair that is looking at coastal resilience, access, and livelihood. We've got a chair proposal for loss and damage, another one for net zero by 2030. Then we've got another chair that is looking at ocean governance. And lastly, we've got a chair that is looking at women and disadvantaged communities and marine spaces. So we are also trying to then build these research programs, stroke research chairs, so that we can open up not only within the Buffalo City, but even across the region, the nation, and globally.
Thank you, Professor. Then Isa Hamid asks, how do you connect wastewater with climate change when wastewater is coming from anthropogenic resources?
Yes, so the connection there between net zero emissions and climate resilient is the infrastructure for wastewater treatment works. Much of the infrastructure for wastewater treatment was done before the world was talking about climate change. So here, they are bound to be vulnerable to extreme, for example, slow onsets, sea level rise. They're also vulnerable to rapid and sudden events. We are now talking about maybe floods, we're talking about tornadoes, we're talking about maybe other related rapid events. So the reason why then we speak about climate resilient wastewater treatment works, like as we move forward into the future, we need then to have some risk assessment in terms of how is this wastewater treatment work going to react in the face of sea level rise, in the face of extreme flood, both on land or in the face of maybe spring tides. So this is how then you start linking wastewater infrastructure to climate change. So as a matter of fact, every other infrastructure, not only wastewater, should actually be climate resilient. You might be talking about roofing of your residential areas. We need climate resilient roofing systems. You might need to move from maybe tiles to chromo deck or other alternatives. When talk about roads infrastructure, it has to be climate resilient. When talk about maybe coastal zones planning, these actually your plans, your physical plans, your settlement planning, it has to speak to be climate resilient. I'll give you an example. In Cape Town, there were rail lines that were set close to the ocean, and some of them now have been abandoned or are being abandoned because there's been now a lot of sand deposition, sediment deposition, and as the sea is advancing, all these infrastructure are becoming redundant. Not only that, a lot of global airports, they are set on the coastal zones. I just dropped here at Brindisi. So you're saying that what is going to be happening there? These airports were set there before the advent of climate change, and now we know. So we are saying that how then do we make these airports or ports climate resilient like any other infrastructure? So you can't dissociate climate change and other issues from our planning, from our financing and many other issues. Thank you, and over.
Thank you very much for all your insightful questions, and a big thank you to our first speaker for such an engaging presentation. The rest, because of time, the rest of questions can be sent to us, and we will handle them to Professor Nhamo. Before we move on to our next speaker, we will take a short break. But before, I would like to announce our next webinar scheduled for February 18. We will be joined by Emanuela Clementi from the CMCC and Gada El Serafi from Deltares, who will share their insights on key topics related to coastal resilience, and this will be another great opportunity to learn from leading experts and engage in meaningful discussions. So stay tuned for more details and be sure to mark your calendars. And now you may feel free to grab coffee or stretch or reflect on this great discussion so far. We will start again in 20 minutes, so please stay with us. We have another exciting session coming up. See you shortly. Okay, good afternoon. Welcome back. And I hope you had a chance to take a short break and recharge. Now we are ready to continue with the second part of our webinar. It is my pleasure to introduce to our next speaker, Cecilia Bittoni. Cecilia is the program manager for the UN Decade Collaborative Center for Coastal Resilience, with a master in economics from Bocconi University and over 17 years of experience in academia and the private sector, including Stanford, UCSB, and Moody's RMS. She specializes in natural catastrophe risks and financial markets. Currently, she integrates climate science and finance at the University of Bologna to support our resilient decision making. We are honored to have her here today to share her insights, and please remember to submit your questions in the Q&A section, and we will address them at the end of her presentation. Now, without any further ado, Cecilia, the floor is yours.
Hello, everybody. Thank you, Edwin, for your introduction. I'm sharing my presentation. Okay, so I need to swap. Okay, where is the swap screen button?
Maybe Cecilia, you want to go to presentation mode?
First, I need to go to presentation mode and then I can swap. Okay, no, this is fine now. Okay. Thank you, everybody. I had the problem with the double monitor. Thank you very much. My presentation's title is Natural Catastrophe Modeling and how they are used for strategies for resilience and sustainable risk management. There are three main takeaways I like you to remember from this presentation. One is what are probabilistic natural catastrophe models. The second one is what is financial resilience to natural catastrophe risk? And the third takeaway is what is the role of the insurance industry? First of all, I start with what is a natural catastrophe. It is an event causing great and usually sudden damage or suffering, a disaster. What is a way of measure a catastrophe? The key statistical measure for a catastrophe event is its return period. The mean interarrival time that represents the expected time until another event with similar characteristics occurs. That is a definition of event return period. For example, it can be calculated as the inverse of any distribution, like a Poisson interarrival time, and the inverse of the frequency of occurrence. For instance, a 200-year event statistically implies an event with a 1/200 or 0.5% chance of occurring in any given year. However, what is important to note is that return period is only a statistical measure and does not guarantee the spacing of events. This means that a 200-year event that occurs today can occur in a much shorter time frame, even in the much nearer future than you would expect. This graph shows the probability of at least one event occurring over time for different return periods events with 10, 50, 100, 200 years. As you can see, The probability of occurrence, of course, increases over time, but shorter return period event, for example, the yellow line shows the 10 years old event, quickly approach 100% probability, which means that they will occur for sure within a shorter time frame. Here we're saying about the 25, 50 years, while longer return periods event take much longer to reach high probability. For a 100-year return period event, there is a 40% chance of this kind of event occurring within the 50 years. Let me now show you some major events we all know, but we'll refresh our minds. This one is a picture of the tsunami caused by 11 March 2011 earthquake in Japan, the Tohoku earthquake. This was a submarine earthquake that occurred in the Pacific Ocean, 72 kilometers east of the Oshika Peninsula or the Tohoku region. It was the most powerful earthquake ever recorded in Japan and the fourth most powerful earthquake recorded in the world since modern seismology began in 1900. This earthquake lasted approximately 6 minutes and triggered a very powerful tsunami. Waves have been measured up to 40 meters. The estimate for the return period of such an earthquake is 800 to 1,000 years. Researchers analyzing sediment layers and historical records found evidence of a tsunami of this main severity occurring about 1,000 years ago. Which was itself caused by an earthquake of similar magnitude in the same region. This earthquake was devastating. It caused many fatalities and an economic cost of 411 billion. I'm going to show you also this image from Hurricane Katrina that hit New Orleans in 2005. This was a Category 5 event with a maximum sustained wind speed of 280 kilometers per hour. The storms produced a strong wind that pushed the water into the shore and led to a major flooding. For a Katrina event, which made of a strong storm, levee failure, and extreme flooding, the return period is estimated at 400, 500 years. Some studies also suggested it could be an event with an even longer return period due to the combination of extreme storm surge and infrastructure failures. Also, Katrina was a devastating event, caused many fatalities and 162 billion economic cost. I'm showing you the image of Hurricane Beryl, which was in 2024, last summer, was the earliest hurricane to reach Cat 5 intensity, Category 5 intensity in the Atlantic Ocean. It was originally a tropical storm that quickly strengthened to a major hurricane and made landfall in the island of Curiaco in Grenada as a high-end Cat 5 on the 1st of July. And later it strengthened even more into a Category 5 hurricane in the Eastern Caribbean seas. And it caused unprecedented devastation across all the Caribbean. This image shows the aftermath of Hurricane Harvey, 2017. Unprecedented rainfall and flooding event in Houston, in Texas. The return period for an event like Harvey depends on the specific aspect being considered. Texas is frequently hit by hurricane, roughly every 25 or 50 years. The flooding impact of the city of Houston, though, it's much rarer, and the return period for this flooding is estimated at around 500-year return. While this event had a particular characteristic of huge rainfall, 50 inches of rain in 48 hours. So for that amount of rainfall, the estimated return period is about 1,000-year-old, based on historical precipitation records. So Houston, as I said, experienced during this event a maximum recorded rainfall. Why is it significant? This is significant because the amount of rainfall occurred in such a short period of 48 hours. Normally, about the same amount of rain takes a year to reach is an annual amount in Houston area. Therefore, receiving 52 inches in just 2 days made it an extraordinary and extreme weather event. This picture shows the rainfall by catchment in the Houston area. Okay, now let me explain or talk about a probabilistic natural catastrophe models. So probabilistic natural catastrophe models estimate the potential loss from natural disasters by simulating event occurrences, intensities, and their financial or structural impact using statistical methods. What is a loss? So in terms of CAT models, the loss is given by hazard and vulnerability and exposure. The hazard is how frequently and severely can a location be flooded. The vulnerability is for a given flood depth. If we're talking about flood, for example, what is expected damage to a specific property, to its structure, to the content of the property, or even to the business interruption that damaged property can cause. The exposure is the cost of repairing or replacing the damaged parts. I highlighted here this very important influencer of the total losses, which is a correlation factor. So when, what is the probability that when building A is flooded, also building B or C are flooded? It has a huge impact on the calculation of the total losses. This is the framework for a probabilistic natural catastrophe model. It consists of 5 modules, each playing a critical role in estimating the potential losses. The first is a stochastic event module. So the idea is to generate a large set of simulated disaster scenarios based on historical data and model data. For instance, for flood, the stochastic event module simulates thousands of hypothetical floodings with different rainfall intensity, streamfall discharge, and so forth, taking into account the major variables for flood events. The other module is models how the intensity of a catastrophe spreads over a geographical area to assess a local severity. For instance, it considers for flooding again water depth. Then the vulnerability module assesses how assets respond to different hazard intensity. The vulnerability model uses fragility or damage curves to estimate the level of damage at different hazard intensities. Then we have the exposure module that defines the asset at risk, including their location, their value, and their characteristics. And finally, we have a financial analysis module that converts the physical damage into economic loss estimates. Let's now see each of these modules individually. Catastrophe models have the same, I had this sentence to show you that the catastrophe models have the same framework for different hazards. So as you see, there are all the 5 different modules. In case of earthquake, for example, the stochastic event modules would simulate hypothetical earthquakes with different frequency, magnitude, epicenter, intensity. And the hazard module will have to take into account other variables, such as the peak ground acceleration to assess local severity. So now let's look at the stochastic and other modules. The stochastic modules simulate thousands of hypothetical events. In case of flooding, events with different rainfall intensity, discharge, as I said before. The hazard modules, wind speed for hurricane or flood depth for flooding, and factors like local geological, meteorological, environmental condition to assess the local severity. The other modules' accuracy depends on the quality and quantity of available data. It allows to answer the question if any property at risk. This map shows water depth at high geographical resolution to classify specific areas at no risk, at medium or high risk. This was done for flooding in Tampa, in Florida, County Tampa in Florida. This image just want to show that modeling flood risk, it's a very complicated process. It requires modeling precipitations or precipitation simulation that needs to take into account other variables such as seasonality, clustering, and other meteorological aspects. Then you need to model rainfall runoff, routing. You need to take into account the presence of defenses, physical defenses, and their effect. And finally, you can get to model the inundation in a specific area. And here I'm just showing the picture of a modeled inundation using a specific catastrophe model from the company I worked for, Moody's Risk Management Solutions, versus an observed real flooding. Let's now move to the next module, which is the vulnerability. Vulnerability module assesses how assets, like building, infrastructures, and so forth, respond to different hazard intensity. It uses fragility curves to estimate the level of damage at different hazard intensity. For example, like a wooden house made of wood, it will be less vulnerable to some events like earthquake than a house built with reinforced concrete. For a given other intensity, for example, wind speed or flood depth, the resulting impact at the local level is measured as physical damage to a structure. This is expressed through a damage ratio, which is the mean damage ratio that quantifies the average percentage of an asset's value expected to be lost due to the damage occurring. So the mean damage ratio is expected cost of damage over the replacement value of an asset. For example, if a vulnerability curve predicts a mean damage ratio of 0.2 for a specific building at a certain flood depth, it means that 20% of the building's replacement value is expected to be lost. The mean damage ratio is a core output of the vulnerability module, and it is essential for calculating the economic losses in the financial module. Okay, we have now reached the fourth module, which is the earthquake module. It modules the assets at risk, including their location, their value, and their characteristics. It covers buildings, infrastructures, crops or agricultural areas, businesses, and population. This is where we can see, for example, that a coastal city with high population density has a very high exposure to flooding and hurricane damage. The most important information needed for the exposure module is the location, the location of the asset we are analyzing. So the geospatial data to identify where the location is. And identifying the geospatial location is the geocoding of the location. It's called the geocoding. Accurate geographic coordinates, latitude, longitude, or addresses are needed. And this allows to determine the proximity of an asset to a hazard zone. For example, close to a floodplains or a seismic fault lines for talking about earthquake, or a coastal area. Again, coastal are very much exposed to damage. Geocoding allows to identify the location soil type. Soil condition can amplify the effect of an event, of an hazard. And again, coastal location may have higher flood or storm surge vulnerability. The exposure module requires classifying the assets according to its occupancy type. What is the occupancy type is answering the question if it is a building. What type of building is it? Is it a residential building or a commercial building? It is industrial, or it is a critical building like a hospital. Or it can be an infrastructure. So are we talking about roads, bridges, utilities, water treatment plants? Or is it an agriculture asset? Or if it is a business, does it have an inventory? The value inside the business can be very high. Estimating population and demographic data are very, very important for the analysis on the human impact. Finally, we see what we need to know, what is the value of the asset. And for value, we use the replacement value or the market value of the asset. The financial module, the last part of the probabilistic catastrophe module, is the final step, and it is critical for converting physical damage estimates from the vulnerability module into economic losses. The financial modules plays a central role in determining the financial implication of natural disasters for stakeholders that can be homeowners, businesses, communities, or even government or local. Key functions of the financial module is converting the physical damage to economic loss. It takes the output from the vulnerability modules, the damage ratio that we saw before, and translate them into repair and replacement costs. It considers partial and total losses across the building, infrastructure, and any type of assets we are analyzing. If a building, for example, has a 30% mean damage ratio, and it has a replacement value of $1 million, the physical damage translates into 300,000 in direct economic losses. The components of the economic losses are both direct losses and indirect losses. For direct losses, we mean repair and replacement costs. So that means that the costs to restore or replace damaged structure, contents, or any equipment. Content losses, damage to any items within the building, furniture, if we are talking of homeowners, but also machinery, if we are looking at a business building. And the structural losses, so damages to the physical building and supporting systems like foundations, walls, heating, ventilation, air conditioning systems. It also has indirect losses, which I mentioned before, and it could be the business interruption, which reflect the lost revenue due to operational downtime, and or any additional cost incurred during recovery. For example, if it's a manufacture plant, the manufacturing plant could halt its production for several weeks due to a specific damage, leading to revenue loss and penalties. And now want to give you this perspective on the difference between physical and financial resilience. The resilience, to repeat, is a capacity to withstand the effect of an extreme event and to recover after an event has occurred. After all the mitigation and adaptation measures have been adopted to limit the impact of an event, which are defined as physical resilience, the financial resilience is where the insurance structure, an insurance structure could take place. What is the financial capacity to recover after an event? In the end, after an event, we want to allow people to have the money to recover, to rebuild, and be in the same position as they were before the event in a short or not so long time frame. These are examples of physical resilience measures. As you can see, some are, this is for flooding, of course, and some are acceptable. You may accept to build a little wall at the entrance of your property. Some are not acceptable. You cannot not be able to enter your own home. These significant flood defense infrastructures have been built in many cities to prevent this. I think this image on the right is Vienna, where a major infrastructure was built to after the flooding of the Danube River. So it's important to have physical infrastructure defenses. But at some point, the physical infrastructure may not be so feasible. Like in this case, you know, he's safe, but not everybody can do the same. So the natural catastrophe models allow you to better understand protection performance, and they allow to investigate both property and community level flood mitigation measures, and also to influence public administration plan and spending. For example, models could show that it won't be useful to build a specific defense that in an area where, you know, which had, you know, maybe a rich area where there is money to spend for preventing an event, but maybe it's not beneficial for the entire community. Okay, so the insurance industry is involved in taking part of the risk of a natural catastrophe, covering part of the losses. This is a brief overview of the insurance stakeholders and how the risk can be transferred from the single individual or property into the market. So we start from a policyholder who can buy a protection to transfer some of the risk to the insurers. Then there are insurance companies. I put here some Italian one because I've done it before for an Italian presentation. And they keep part of the risk, and they will cede some other risk to reinsurers. Reinsurance company, they buy some of the risk from the insurances, and they keep some because they have huge portfolio, which they can diversify their risk, and then transfer some other risk to the financial market. This passage between insurance and reinsurers is helped by the reinsurer brokers. So brokers, like you may have heard, this big Aon or Guy Carpenter's, Willis Towers Watson, they're brokers that they transfer some of the risk from the insurer to the reinsurer. And then finally, through a specific financial structure, some of the risk can be ceded to the financial markets. And the investors buy this risk because it is an uncorrelated risk to the financial market. So it's a matter of diversifying the portfolio. And the catastrophe models quantify this risk, and in a way is used, the catastrophe models can be used as a currency along this risk transfer chain. I'm about to conclude my presentation. Strengthening financial resilience to natural catastrophe has some challenges, while developed countries have, a system to manage catastrophe risk, or somehow, not so well, not so good, but some countries can. Developing countries face limited resources, and that leads to greater loss and slower recovery. There are attempts of solutions which are helped through the adoption of probabilistic cut models, and consist in risk auditing methods that can help design cost-effective policies or different structures of new type of policies that can be used in different countries. International institutions like the UN are driving a global collaboration to address these challenges. I think you may have heard of the Sendai framework, which has been underwritten by 120 countries in 2015 and is a voluntary, not binding agreement, which recognizes that the states has a primary role to reduce risk, but that responsibility should be shared with other stakeholders, including the local governments, the private sector, and other stakeholders. And the Sendai framework aims at achieving a substantial reduction in disaster risk and losses in lives, livelihoods, and health, and in the economical, physical, social, and cultural assets of people, business, communities, and countries. Another framework is, as you know, the Agenda 2030 for Sustainable Development that incorporates goals on improving disaster resilience. Okay, so I had this one was a definition of the Sunday framework for disaster risk reduction and the Agenda 2030 for sustainable development. So I'm about to conclude my presentation. So these are the takeaways from the beginning. So what are probabilistic natural catastrophe models? They provide a more comprehensive understanding of risk by extending analysis beyond historical record. What is a financial resilience to natural catastrophe? It is the ability to build more sustainable societies and economies. And finally, what is the role of the insurance industry? It provides financial resilience, enhancing the capacity to recover from catastrophic events. I leave you with a sentence from a geographer, famous geographer, Gilbert White, who says that natural disasters are acts of God, but natural disaster losses are largely acts of men. Thank you, everybody.
That was another excellent presentation. Thank you very much, Cecilia, for this insightful presentation. And once again, we will open the floor for questions. So if you have any questions, please use the chat function, and we will. I am checking right now, and we already have some questions. First, Carla Schulte asked, as far as I know, we have the problem in Germany that water catchment areas often extend over several municipalities. which makes it difficult to issue reliable flood warnings in good time. How is this regulated in other countries, and to what extent has this proved successful, and how does this affect the reliability of models?
Okay, so if I understand the question, okay, if I understand the question is yes, on how you're saying how the water catchment areas, they are one and in different municipalities, which it does not impact the models. I mean, what the geographical location, the geocoding of a location, it's not necessarily related to the municipality definition, to the geographical according to the municipality or the postal code. So I would say that you need to analyze it better. The more data you have, the better and the highest the quality of data, for example, using satellite data, will allow you to determine the mean damage of each specific catchment. And then municipalities need to talk to each other to decide which is a measure that they can implement that would affect not only themselves, but even the other municipalities. So it is necessary, very important to increase the communication and the ability to share this information across municipalities or for entire countries, or even sometimes across countries, because there are events that may cause effects on different countries, not only different municipalities. I'm not sure if I answered your question.
Okay, thank you very much. Yes, usually they have water catchment authorities as well to coordinate between different municipalities in real time.
Exactly.
We have another question. Do the model include nature-based solutions as a prevention element?
Yes, I mean, the model is an observation of the reality. So if you need to model, one thing that I may not have expressed clearly is that a model is a peril region. They're always called peril region models. So US earthquake, California earthquake, US hurricane, Japan typhoon. These are the way we define perils. So it is important that the data again are correct. So if we are modeling flooding in a specific area, we should analyze what measures are in that area and take into account in the models and modify. What the models allows you to do is to modify a nature-based solution or add a nature-based solution to the model to change the effect on the vulnerability curves deriving from the models. So you have a lot of flexibility to introduce variables that modify the type of solutions that are already implemented in the area or that they could be implemented.
Okay, thank you very much. And then we have Elena Karisova. If we have an idea for coastal resilience, who should we address? Policyholders, insurers, reinsurance brokers? Who should be our market for easier adoption?
Okay, so of course, the insurance company are a profitable company. They want to make money out of what they do. So the idea here is not to let the private sector handling the risks, also because they can't. An insurance company will insure you only if the risk is good enough for them to make money. So if there are very high risk areas, and we've seen this now with the wildfire in California, for example, insurance stop insuring for wildfire. It's too high for them to write the policies and repay for it. Many of the major events I've shown you in the picture below led to several insurances to be out of business. So what it's very important is to include the insurance market into a discussion with our governments and local institutions, where they can define agreements for which the insurance cover up to a certain risk, but above that risk will be the government who takes care of it. There is an example which is very interesting and should be studied about in the UK for floods in the UK. There is an agreement between the UK government and the insurance sectors for which, for flooding, again, I said it, there are some areas in the UK where the risk of flooding is very, very high. So the insurance won't cover for flooding there. So the agreement with the government is to let the insurance ask for a little bit higher premium from properties that don't have such high risk of flooding, and cover up to a certain level of loss. Above that loss, the government takes a responsibility of covering above what and for what for those properties that the insurance are not insuring, basically. And so this is again to say that if you have any idea of a policy, should be talked to the local authorities and hopefully open the discussion also with the private sector, with the private insurance sector. An agreement between private and public would be an ideal solution. And there are some that can be used as examples.
Okay.
I hope I answered.
Thank you, Cecilia. We have another question. It said, how does the flood mitigation model links with the insurance? Which aspects are mostly excluded?
I'm not sure I understand the question. Will the person, I don't think the person who wrote the question can speak. Can they speak or not?
Susanta, are you able to unmute your microphone and repeat the question?
No, probably they can't speak.
Okay. Maybe meanwhile we will go to the next question.
So anyway, I want to say for the person who asked me this question, if I'm going to take down all the questions in the chat, and will take my time to answer you more appropriately. And I worked with Annalisa and Edwin at the DCC-CR, so you can send me the other questions if you want through our email, the DCC-CR email, which all the students must have. Okay, thank you. Please, Edwin.
Okay, thank you very much. I'm just going to share my screen again, and okay. once again, thank you very much for your questions. And before we wrap up today's session, I am excited to announce again our next webinar scheduled for February 18, where Emanuela Clementi from the CMCC and Gada El Serafi from Deltares will share their insights on key topics related to coastal resilience. This will be another great opportunity for you to learn from leading experts and engage in meaningful discussions. So stay tuned for more details and be sure to mark your calendars. And finally, thank you all for your participation and engagement in today's session. Special thanks to our speakers for sharing their valuable knowledge with us. And if you have any follow-up questions or would like to connect further, you may use the chat, and for the participants of our co-growth course, they may use the students forum in the platform. Once again, we encourage you to connect with our partners, explore their initiatives, and engage with the broader community of practice where you can continue this conversation beyond this webinar. We appreciate your time and look forward to seeing you in future discussions. Have a great day. Bye-bye.
Goodbye.